All right. I think YouTube now says that I am live.
Should I refresh or? Well, people say hello. People are saying hi. Okay, I see it.
Perfect. Okay, so they can probably hear both of us now.
Yeah, I'm going to keep my YouTube. Well, I'm going to turn on the mute. I'm my YouTube. I
Sure.
can hear myself over the YouTube. It works.
Yep. Awesome. Okay. All right. We are good. Hello, everyone. Welcome to the May edition of our Edmonton Python user group. We're found online at EdmontonPy.com. You can also find us on Twitter. We're in the Dev Edmonton Slack under the Meetup-EdmontonPy channel, and we also have a YouTube account, as you are viewing us on right now. We do have a playlist of videos that go all the way back to June of last year. We'd like to thank Startup Edmonton, even though we're not meeting in person. They have been a huge supporter of us for many years now. So we just like to thank them for offering their space. And hopefully one day we'll be able to get back to meeting in person. And it, definitely wouldn't be a talk during this time if I had neglected to remind everyone to make sure to stay up to date and read about any resources that both governments are providing on the situation. So this is a rule that we apply when we meet in person, but I thought it'd be good to also mention here as well. It's called the Pac-Man Rule. And basically, when you're standing as a group of people, always leave room for one person to join your group. We like to keep this very open. We have talks that range. They span a bunch of different topics, and we'll cover advanced topics as well as beginner topics. And we just really try to foster that inclusive community. Looking at jobs, so locally we have Sam Inc. is looking for a senior full stack developer. I looked at that job posting and they are looking for someone with Node.js and Python skills. And Meadow.ai is looking for a machine learning engineer as well as a software dev intern. Online, there's also once a month, there's always this Who is Hiring post on Hacker News, and being hackers, people will create ways to scrape that information. So hnhiring.com is exactly that. As well, there's also remotepython.com and remoteok.io to look for any remote positions. As well, we do have an opportunities channel at devedmonton.slack.com, so take a look there. In terms of events, PyCon had to move everything online. But the really awesome thing is that I did take a look at the link here in these slides. And I have a link to these slides within this YouTube video. So after this, feel free to take a look at the numerous tutorials and talks that PyCon has compiled. And it's all the talks, all the tutorials that they were going to present at PyCon US, but instead they're now on YouTube. In terms of news, Python 3.9.0 Beta 1 was released on May 18th, and Django 3.06 was released on May 4th. We also have a couple of podcasts here. Real Python episode 7 they've actually got the maintainer of the Black library, which is a code auto formatter for Python. He's the guest speaker on that Real Python podcast. They also talk about async IO and what it's like to manage different Python releases. For podcast Init, episode 259, they talk about building Python web applications with Fast API, and that caught my attention because I've done a lot of Django and Django REST framework implementations, but it's always nice to see another library that uses async IO and is hopefully going to be more performant. And Testing Code episode 110 is talking about testing in Django. So moving from the built-in unit test module in the Python standard library to using something a bit more Pythonic, i.e. PyTest, and how simple it is to make it happen. In terms of articles, there's been quite a few within the last month. Chris Moffat talks about exploring an alternative to Jupyter Notebooks for Python development. it's pretty interesting. I learned that the alternative is VS Code, and apparently VS Code within the last, I think it was early 2020, released support for opening Jupyter notebooks. So Chris has kind of gone through, he's used Jupyter notebooks for a couple of years, and he just talks about using VS Code instead and the pros and cons of that approach. As well, RealPython has released a new tutorial on regular expressions in Python. It goes from the very basics to getting to be fairly advanced. So if you've had to deal with regular expressions, you know how complex that can be. And RealPython, I find the tutorials most of the time can be really, really good. So take a look at that. As well, the Python Software Foundation has summarized the Python 2020 Language Summit, where a bunch of different maintainers of the different, at the risk of using the wrong word here, different like Python runtimes, they have maintainers of those all meeting together and talking about the language itself and how to interpret the Python language moving forward. Heineck then talks about why you should document your tests, and I found that to be a really quick but useful read. A lot of times I go into test files and it just says test.input is correct. Well, what does that mean exactly? This blog post goes into how to flesh out your documentation to make it explain the why and make it useful to someone, including yourself, looking at that code base 3 to 6 months later. A little bit of a fun one here is someone had created a Game Boy emulator written in Python, and Not a Monad tutorial interviews this individual and kind of picks their brain in terms of like how did they build that emulator. And last but definitely not least, there are a bunch of solutions nowadays for web applications to cache your static files and a bunch of other things. But testdriven.io is a quick tutorial to introduce some of these concepts in a way that is a bit more self-managed than using something like Cloudflare. But I believe that the benefit of learning to do it yourself is that you get to appreciate kind of what Cloudflare does, but at the same time, you start to learn the pitfalls and the different strategies that are put in place. And you'll be surprised how much Django provides for you out of the box in terms of caching. So if you've tried to jump straight to using a CDN and it hasn't worked out for you, give this testdriven.io tutorial a look and learn about caching in Django. So this month's Python tip is the pprint module. A lot of times in Python, when you print out large dictionaries and lists, they can be hard to read. And here I'm using a library called Faker. It's actually one of my favorite Python libraries. I didn't know how to just create a big dictionary from scratch, and well, that's what Faker does. And so here you can see that there's just by default, when you just have a dictionary, it just kind of outputs it in a single line that is wrapping in my terminal, and it's a little hard to read. But if you import from the pprint module, double P, which is new in Python 3.8, you can basically wrap a variable, or in this case, fake.pydict has a function call that returns a dictionary, and PrettyPrint nicely formats that out onto your terminal and just makes it that much easier to read. If you look at the link to the pprint module, pprint, you can control how it pretty prints and all that stuff, but out of the box, you can already tell that it's at least to me, a lot easier to read right out of the box. So our next meetup, I would say is like possibly in June. We are looking for talks, and beginners are more than welcome. So talks do vary in topic. They just have to do with Python in some way. The best way to reach us is through the Dev Edmonton Slack. Right there are 4 different people who are on Slack regular enough to let us know if you want to present on something. We do encourage that beginners start to talk about their projects, because we have noticed there's been a bunch of people nowadays learning how to code, and they're coming in and learning Python. So even if you feel like you're a beginner and you don't think your talk is, well, relevant, I have to say that it's probably more relevant now than ever. And we've had talks about people building projects, trying out different libraries and all that. And we encourage people to present on what they've learned. So again, let us know. Otherwise, June is still kind of up in the air. We're going to do our best and stay up to date with what the government is saying about in-person events or virtual. So today's talks, I'm going to dovetail straight into my talk, and this one's suitable for beginners, talking about debugging with Pdb. And after a short question period, we'll then dovetail into Abram's talk on really basic optical mark recognition with the OpenCV library, but using a Python interface. All right, so bear with me as I do a quick Alt-Tab to my other presentation on debugging with Pdb. So in terms of the outline, because I'm approaching this presentation from the top, from the perspective of someone who's a pure beginner, I wanted to talk about what is debugging first and foremost, and then second, why would we debug? Then I can then talk about what is Pdb specifically, and then I'll go into a bit of a toy example on basic Pdb usage and basic commands that even today I still use a bunch. So first, what is debugging? Based on the Oxford Dictionary definition, it is the process of identifying and removing errors from computer hardware or software. But anecdotally, debugging is what I resort to when just looking at the code and the problem doesn't result in a root cause. So as much as I try to slowly play back the code and guess at, and assume what it's doing, there are times when just looking at it doesn't give me a light bulb moment or say, oh, okay, well, this is the fix I need to apply. And that's when you have to introduce a debugger. So why do we debug? If I had to distill it down into 3 points, I would say it's to provide a better understanding of our code and our system at runtime. We make a lot of assumptions, and ideally, we are also writing tests to make sure that we're covering the code that we've written. But even in doing all of that, there will be times when you just struggle to identify root causes of these elusive problems. So by slowing down the code, pausing the execution of your program, debugging can help to remove the underlying bug in our coder system by allowing us to identify the root causes. And sometimes it's as easy as making a couple code changes here and there, but you might also realize that it's more than just your code. It could be your infrastructure. It could be how it's set up. Debugging by slowing down the application, again, can give you the time and the space to understand what exactly is going on. So now what is Pdb? Pdb stands for the Python debugger. And if you're coming into this talk with familiarity with IDEs like PyCharm or VS Code even, with their own GUI style debugging, they're great. They make it really easy to get started. But Pdb is a command line debugging tool. And the nice thing about it is it's built in with every Python distribution. You may find yourself, well, hopefully not, but sometimes you may find yourself at an unfamiliar workstation, not your own computer, not your own server, and maybe the IDE is not set up on that server, but it's deploying Python code. Well, you already have a debugger. It comes with every distribution of Python, so might as well learn how to use it. So we're going to go over some basic Pdb usage. I'm going to first introduce our buggy script. It's a toy implementation. I'm pretty sure some of you or a lot of you are going to just be able to know how to fix the bug right away. But I found it tough to actually be like, what's a good problem to debug? So I just created a toy implementation, which will allow me to show everyone how to invoke the debugger and then a couple common PDB commands. All right, so our buggy script here is a toy implementation summing a list of numbers. Unfortunately, it is crashing when we run it. I did make a comment in line 8 that please, in the real world, use the built-in Python sum function instead. I just built this toy implementation and toy script just to show PDB and how to use it. So what happens if we are to run this buggy function? Well, you can see here that when I type in Python buggyfunction.py, unfortunately, it's giving us this type error. And again, if you have done some Python work, you could probably tell already what the problem is. But let's just use this to learn PDB. So invoking the debugger. There are two ways to invoke PDB. You either call Python and then import the PDB module and then pass in your script file as an argument. Or, and this is the method that I use 99% of the time, you set a breakpoint from inside your code. And to do that, you type the breakpoint. You make a function call to breakpoint. And it's been this way since Python 3.7. So I did make a note in these slides that in the old way, so pre-Python 3.7, import PDB, semicolon, PDB set trace, still works if you prefer typing more, but come on. Also, please remember to delete these breakpoints before you deploy to production. I have definitely done it before, where I did not get rid of these breakpoint calls, and you are not in for a good time, because if you haven't set an environment variable to disable breakpoints, your Python interpreter will just stop at that breakpoint if someone was to make an HTTP request on that and trigger that breakpoint. All right, so after invoking PDB, you're going to then be provided with a bunch of different information. So here we're going to see right away that instead of crashing or anything, our program has essentially paused. And we can see what file is currently being debugged. It says buggyfunction.py, as well as the current line that we are paused on, line 13. And then PDB will also describe our variable scope or context. So we're currently in the sum of list function, and that means that we can inspect the local variables and variables that are available within the sum of list function's scope. Last but definitely not least is this dash and angle bracket symbol to make it look like a 2-character arrow. That shows what the code on the paused line. So this is where I have to be very explicit about what's going on here. Python PDB has not executed this sum plus equals step in line. It has just paused right at the start of it. So if we don't give it any commands at the moment, our program essentially just is stuck here. It's going to be frozen in place on line 13 on this line until we provide it some commands. So here, I just wanted to start off by saying, if you are not familiar with PDB, don't worry about it. There are 8 commands here, which can be quite a bit to absorb right away, but I'll be going over each one by one. And at the end, there's also a really nice, useful cheat sheet to you can print out, and that way you don't have to necessarily remember all of these commands. So give it a quick glance, but I'm going to go right away into our first command here of Q. So Q, or quit, is to exit PDB and to abort the program's execution. And this is because PDB doesn't know what code is going to run after the breakpoint that you've set. So instead of quitting and continuing to run your program, it's just safer for PDB to abort the program's execution. And when you do that, it's pretty cool. It's using the built-in Python behavior of when you raise an exception, it will abort your program. So you can see here, PDB basically raises its own exception here called Pdb quit. and you get kind of the same like stack trace error messages and whatnot that you might have seen when we had tried to just run the buggy function and it crashed. A note I wanted to make here is that when you are working on web projects, this aborting of a program's execution will terminate in the HTTP connection. So for example, if you're building a Flask application with an API endpoint and you've set a breakpoint in your view controller or business logic that is called by that view controller, if you are to quit PDB, instead of responding to that HTTP request, it's going to terminate it, and your browser will basically get connection closed. So the next one is P, and then expression, which prints the expression. And the expression can be a single variable. So you can see on the 4th line of our buggy function printout here, I'm only printing out a single expression of what value is stored under the sum variable. And right now it's 0. But you can also comma separate a list of variables. And in that case, PDB will return a tuple. As a pro tip, the PDB prompt is also a Python interpreter, but you do have to be careful because, as you can tell already, there are 8 different, actually there's more commands than that, and these commands are basically reserved characters in PDB. So while PDB is a Python interpreter, you do have to be careful. If you have a variable in your code running and it's got the name P, well, it's just typing P is not going to return the value of your variable P. It's actually going to be interpreted by the PDB prompt as the print command. So typically my best practice is to, if you wanted to print out an expression, is to just prefix it with a P space and then enter your expression. There is another way to do it, but again, I leave that up to you. In a couple other resources that I will provide at the end to learn about more ways to avoid naming collisions. So kind of alluding to the Python tip of the month, how do you pretty print something? Can you do that in PDB? Before, I don't even know how, but I was actually importing the pretty print module before I found this cheat sheet, but it turns out PDB already comes built in. You don't have to import a pretty print module or anything like that. You just enter 2 P's and then the expression, and it's going to pretty print that expression for you. Now, in this example here, our toy implementation doesn't really have any sort of gnarly, large data structures or whatnot, but you can even see the pretty printer sorts the dictionary. Locals is a built-in Python function to basically print out in a dictionary what are your local variables, their names, and the values that are stored under them. Pretty printing is sorting it by the alpha sorting it by the key. So that can also still be fairly helpful. And I kind of jumped the gun there, but pro tip is to make sure you are using P and double P to safely interpret your expressions and prevent the collision with any PDB commands. Next is L, or list, and then a couple optional parameters, first and last. So if you just type in L, it will actually show 11 lines of source code around the current stoppage point. So again, to review, where are we stopped right now? We know that we are in buggy function.py. We are stopped on line, we are paused on line 13 in the sum of list scope. And if I type L, hit enter, I can then see the 5 lines above and 5 lines below the line that we are currently paused on. If you are to specify a number for first, it will show 11 lines around whatever the number is that you've provided for first. And adding last will return the code within that range. So I'll just go into my terminal now. And you can see when I just try to run the program, I am not, it is not invoking PDB, and that's because I don't have the breakpoint set right now. So I will do that right here. And we will just add the breakpoint. And if we are to run it again, now you can see that PDB has been invoked and is now paused on sum. So again, as in the example in my slides, if I type in L, it now shows the 11 lines of code around it. And then if I say, oh, this line 18 looks kind of interesting. Let me just type in L space 18. Now it's going to show the 11 lines around line 18. And then just to really be complete about this, what if I said L1, comma 18? Well, this is going to then print out your lines 1 to 18 inside of your script file. And it is pretty safe. So like if I was to type in like 1, comma 900, it's not going to error out. It will show you that there's an EOF. So it says, okay, your entire file is essentially 26 lines long. So I actually really like that. Just a nice, I guess, another pro tip of sorts. All right, moving on. The next command is called next, or N for short. And essentially, N continues the execution until the next line in your current function. One quirk, one thing that maybe you may not be used to until you've kind of done debugging over and over is when you place your breakpoint inside of a loop, the quote-unquote next line is actually the start of a new iteration through your for loop or whatever loop you have your breakpoint set into. Now, this can get tiring if you are looping over several items. So, for example, right now, where are we? Oh, let me just quit out. And where are we currently? So if I was to just type N, which will execute line 13, you'll see that PDB prints out the quote-unquote like next line in our program's execution, which turns out to be another iteration through our for loop. So I type N again. Okay, we hit the breakpoint. That doesn't do much, and so on and so forth. That can get tiring, especially if your list has more than 5 elements. I won't cover it as part of this talk, but there is another command called until, which can help you get out of these situations. The next command is also known as stepping over your code. You may have seen that as a concept if you are using something like PyCharm. And it's called stepping over because the debugger does not pause inside of the step in function. It just calls that function and gets the return value and then moves on. So we're not inspecting the logic within the step in function. We just run it, and it basically runs at near real time, and we stay within the scope of our sum of list function. But let's say you actually did want to inspect step in. Maybe this is the function that is causing all of your bugs. Well, to do that, you have S, or step. And this executes the current line, but then pauses at the first function call. If you are to use step on a line without a function call, then it is essentially the same as using next. But if we can see where are we currently, we're on line 13 and we are paused. If instead of typing N, I type in S, you can see now that PDB says, okay, I've detected a function call that's about to happen, but it has not happened yet because as you can see with the 2-character arrow symbol, we are at the top of our step in function. So it hasn't run it yet. So I will tell PDB, all right, N, let's execute this line and then pause on the next. All right, so now it has gone, comments don't count. It's just going to skip over those. It will now go in. And this function doesn't do anything, just here to demonstrate stepping in with PDB. And we can see that if I execute line 22, it's going to return the num value that was passed in. Now, let's say you stepped into a function, and as you're building more complex apps and you're debugging real-world applications, sometimes you might find that you're stepping into a function and you realize, actually, this probably is not the function that is causing my issue. instead of having to type n and then like spam enter over and over and over again just to get out of that function, you can type r, which executes until the current function returns or crashes. Note that typing r will cause PDB to report to you what value was returned, which is quite helpful. So in this example here, we stepped into the step in function, but we've gone through this loop a couple times and we've realized, okay, step in, it's just returning a number. That's it's returning the num variable, sorry. That's probably not what's causing our issue. So if we type r, even though it's paused on the 18th line in our source code, it will just execute the step in function and then report the value that step in returned, which in this case is 2. Here in this bottom example, we tried to step out of sum of list. So we're in the sum of list context, but PDB found another breakpoint inside of the loop. So PDB by default, it's not going to continue running your application or return out of that function until you've gone through and passed all of the breakpoints that you've set. And it might be a little bit confusing when you are working with breakpoints inside of a for loop, but hopefully this is starting to make sense. So again, right now, if I tried to, where within the context of sum of list, if I want to say, hey, PDB, I don't want you to go through this whole sum of listing, I want you to return. Well, it's going to pause because there is a breakpoint still that needs to be evaluated because we haven't gone through our entire list. So let's say in this example here, I've actually moved the breakpoint out of the for loop just to demonstrate the next command, which is C or continue. And this is a little bit similar to return in that it does continue the program execution and it pauses only for breakpoints. But the difference between return and continue is that return will it will run until the function that it's currently in returns a value, and then it will pause. Continue will basically try to execute as many lines of your application as possible until it runs into another breakpoint. So again, I've moved the breakpoint out of the loop, and if we are to then run PDB with this code change, and I have it paused, but I say, hey, continue, it's going to run our application, and because we haven't fixed the bug yet, it's going to crash. So we basically get normal behavior with as if we didn't have PDB invoked whatsoever. So to show that, I will quickly move this breakpoint out. And I will paste, I'll paste that in here. And yep, it's good. And so because we've placed the breakpoint on line 9, and again, we skip blank lines and comments, PDB is pausing just before the loop. And if I type in C, all right, our program executes to its completion, which in this case results in a crash. Okay, so now let's put all of these commands together. Let's once again put, let's actually run our application again without any breakpoints, just to reset our minds here and see what our application currently does. And all right, so it's crashing. And I can see that in the traceback, it says line 25 in module. Okay, well, that doesn't quite mean much to me. That doesn't look like something that I can address. But if I go further down into the error message, line 12 in sum of list. Okay, so it's having some problems on this line. So I'm naturally inclined to set a breakpoint just before what was line 12 and is now line 13. So now if I run this again, it will invoke. And it's here where I actually want to see at the very first iteration of our loop, what is the values of sum and I? All right, so it's 0 currently for sum and I for our loop variable. And just to refresh us, where are we currently? Okay, so this is the first iteration through our for loop. It makes sense that sum is 0 because that's how we initialized it. And num list, what is that? Oh, okay, so this is, and I probably should have used p here, but I know that num list is not a command or it won't collide. And so I'm basically going back to the Python interpreter behavior, and I can see that, all right, this num list has 8 elements in it. Okay, we've stepped in, we've seen what step in does. It really doesn't do much, actually. So we can see that is probably not the culprit. So if I was to hit continue, our application will continue, and then until it reaches a breakpoint, which in this case is a breakpoint within our for loop. Well, now what is in our sum and I variables? Okay, this makes sense because our command is saying add 2 to whatever value sum has. And so now sum has gone from 0 to 2. And I is 3 because that would be the second element in our list. Okay, that looks good. Let's continue. And what's going on here? Okay, so we've added 3 to 2, and we get 5 in the sum. That makes sense. Now I is 5. Okay, if I hit continue again, all right, that works. That worked again. And then 7. Okay, let's continue here. And oh, okay, what happened here? My application has crashed. And if we are to look really carefully at what's going on, that's because in this case, in my little toy implementation, we can see that it is trying to add what is a string to an integer. And Python doesn't allow that. It will raise a type error. And that's why at the very start of my talk, I said, if you know Python much, you can probably already tell what the error is. But here, as I'm showing, you can actually have your program behave properly through a couple iterations until suddenly you meet this very specific instance that will cause your application to crash or behave abnormally. And this is what my example is trying to show, is that, look, this list of numbers has a bunch of integers, and then suddenly, somehow, this function was passed some unclean data, and Python doesn't allow you to add strings to integers. So in my example here, what did I use? I used the quit command. I was using print a lot. I was using continue. That's actually what I use basically all the time within Pdb. Now, again, like I said, there are many more commands that will make your debugging life easier, and I just can't go through all of them in one talk. But I do recommend that you take a look at the Python official docs. I will have to say that the official docs doesn't quite lay out the PDB module in a way where it's easy to just like learn step by step, which is also why I've provided a real Python tutorial that actually does kind of build. It overlaps a little bit with my talk, but then extends upon that by showing you a couple other commands in PDB. And last but definitely not least is a link to a PDB cheat sheet, which I have here as well. I have actually got this printed out, and it becomes my reference point for all the different kinds of commands that are built into PDB. So you don't, again, that's why I said at the start, don't worry about trying to remember what all of the commands do. The main point of my talk is to highlight how powerful the built-in debugger is and how it can help you slow down the execution of your program, which should allow you to identify the root cause of your issues. So with that, I'd like to thank you for your time. This talk is available under my GitHub. So it's basically just the buggy function without the breakpoints. And it does have a link to these slides, as you can see here. otherwise I'm just going to open up the floor to any questions within the YouTube chat. Okay, doesn't look like we have any questions. So Abram, I think it's time, if you're still there and I haven't bored you with PDB talks, if you're still there, I think it's ready to switch over to you now.
All right. Can you hear me?
Yes.
Okay.
Perfect. And I can see myself on your screen. So we are good to go. Sorry.
Right, but you have some questions.
I do. Yes. Thank you. Yeah. So Ildar is asking, is there any debugging GUIs? Yes, there are definitely GUIs for debugging. And it's if you're using something like PyCharm IDE, it will come built in with a debugger that has buttons for you to step over, step in, and step out. It will probably also have a nice area to show you the local variables and your stack trace and whatnot. VS Code also comes with a debugger built in. I don't know any other debuggers. There has to be other ones. I've done a lot of my work either through VS Code or just using PDB on the command line. Alex does raise a good point that IPDB is it's really good because it introduces syntax highlighting and a bit better introspection. I think IPDB also provides you some tab completion. So it is still a command line tool, but it kind of gives you some of the nice to haves that, let's say, something like VS Code with syntax highlighting, or Vim, if you have syntax highlighting enabled, like I did, it provides that. So yeah, I'd say look at what code editor you currently use and basically try to see if it does come with a built-in debugger. And if not, hey, there's PDB for you, right? So the next question I'm getting here is, will PDB be useful for Flask and Django? Actually, that's where I used it a lot. And that's why I made a note in my talk to say that when you add a breakpoint to your business logic or to your view controllers, what happens is your website or your mobile app or whatever you have will make an HTTP request. And then in your view controller, it will then make a call to the business logic or wherever that breakpoint is set. And then that's where PDB gets invoked. And you see the same things as what I was showing in my talks in the terminal, where you start to use your PDB commands to step over, step in, step out, and to inspect your variables. So it is especially useful in Flask and Django because I use it a lot to inspect what is in my request body, what is in my request header, and then not only that, what is my Flask SQL Alchemy ORM returning, or what is my Django ORM returning. By slowing down the code, I can dissect my business logic step by step to be able to narrow down where my root causes are for whatever abnormal behavior I'm noticing. So hopefully that answers your question, Luke. I will say though that it does. If when you quit out of the PDB session, it will terminate the connection, but there's also Jango Shell. So the Jango Shell is interesting because when you're inside of the Jango Shell, you're not necessarily making HTTP requests. Now, I know you can, but a lot of times I'm debugging the interaction between a mobile app calling my Django REST framework endpoint. And if I open up the Jango shell, yeah, I basically use the Jango shell as an area to test out some ORM queries and whatnot. But I just find that for me, it's just easier to have a mobile app or a web service make that API call. And while it's running locally, I type in the breakpoint function call, and PDB will trigger, and I have an open terminal where I typed in like python manage.py run server. Well, that automatically becomes a PDB session. And now I'm able to actually stop and execute on my own terms, on my own time, the exact code that Jango will run through to process whatever request has come in. Okay, sorry about that, Abram. I think now would be a good time for us to switch over to your talk. If there are any more questions, please just keep firing them through. I will. Awesome. Okay. Yeah, if there are any questions, please feel free to type them in. We will get to them at the end of each talk. All right, Abram, take it away.
All right, thank you. So thanks for that talk, Aaron, about PDB. It's especially useful just to be able to actually put breakpoints directly in code. It's quite handy. Today I'm going to talk about either like an intro to OMR or baby steps into OMR. I can never keep the title constant, but what OMR is optical mark recognition. This is different than character recognition, where you might draw something. You might write something down and expect to scan it and expect that the characters will be interpreted by the computer and converted into actual characters that your computer interprets. OMR, its intent is to scan marks. So you probably have written a bunch of tests and filled out a bunch of forms that ask you to fill in bubbles or fill in squares. Those will use optical mark recognition. Some of them use physical ones where they actually detect if there's like a number 2 pencil scribbling in the bubbles. Others will be totally optical and just rely on scanning. So I got interested in optical mark recognition because I was giving students in class a lot of paper exercises. And I really just wanted to be able to know if they wrote the exercise, if they were in class. So I asked them to bubble in their student numbers. And this allowed me to quickly scan using like a Xerox scanner, quickly scan in a whole PDF of their stuff. And then I had to interpret it somehow. OMR is what is supposed to interpret those bubbles, but I couldn't find a really nice off-the-shelf OMR that would work for my case. Many of them ask you to follow their workflow and design an OMR sheet yourself. So what I wanted to do is basically do OMR myself. So we're going to start. The libraries we're going to be using today are Matplotlib, NumPy. I'm using Jupyter Notebooks here just for presentation purposes. But the big library we're going to use is called OpenCV. That's Open Computer Vision. And it's going to do a lot of work for us. So when you want to do OMR, typically you have to follow a certain process. So typically what you do is you scan documents, you then normalize the documents, mostly to clean up code, and you keep the size consistent. Oops. You want to like normalize for size, you want to try to detect orientation, and you want to rotate them correctly because sometimes the scanner is off a couple degrees. And if you've got any guidelines on your sheets of paper, you probably want to align your sheets of paper with those guidelines, or detect that a sheet of paper is upside down, so you flip it 180 degrees. You might also find that your scanner is inconsistent and its output in terms of brightness or contrast is not great, so you might have to modify that. Once you've normalized your documents, the first step is typically finding the template. The template is going to be the OMR thing that you click on. So I'll just show you an example right now. Let's see. So here's an example of one of my quizzes, right? And you type in the student number, you scribble in the boxes there, and then you write on the rest of the form. So the first step is going to be we have to find out where this box is. And then the second step is once we know where the box is, we want to read these numbers. Okay? So we want to find the template, we want to extract the template, and then we want to interpret the marks on the template. And then we obviously want to output the results. We probably want to put into a database. So that's how you generally do OMR. But when you're building an OMR system, you also have to engage in evaluation to make sure you know if OMR is working. This means you scan and normalize your documents. This means you have to laboriously manually label the documents with the correct results, which took me a long time when I did it. And then you apply the OMR process, and then you compare your results. So if you're optimizing it and producing better results, you might use something like accuracy, where it's the number of correct versus the number of total of things that you marked out. All right, so that's how we start with Omar. First off, we have to make a template. I made this template, so copy image location. Let's see if that works. No, that did not work. The template is over here. And you can tell that this is not the computer template I made. This is something that I scanned in and just cut out. All I wanted it to say was student number. It's got numbers down the side and boxes you fill in. Now, the important thing here is that it's taller than it is wide, so it's not perfectly symmetrical. And the student number, it has text in it, so that's kind of an interesting feature, and there's numbers down the side. So this will make it a lot easier to recognize it. If this thing was perfectly symmetrical, it'd be quite problematic. So I hope you can read and see that. All right. Try to keep it clean. Don't use a scanned crappy one like I did. Try to use your original if you can. And also know the DPI of your scanning ahead of time. When you're designing this, consider features that you can use. You've probably seen a couple of them. And if you can in chat, share with me some examples that you've seen. I've seen things like a rounded corner. I've seen cut off corners where it's not a rectangle, it's kind of rectangle with a little notch in it. I've seen the use of asymmetrical shapes. I've seen people put corner markings on things. And I've also seen just generally consistent placement on the page to make the finding of it a lot easier. Also, I think I made a big mistake when I use squares instead of circles. Why? Well, the problem is that circles, you kind of fill in slowly with a pencil and to a certain speed, and it's kind of a natural human motion, whereas a square requires you to fill out the corners, and you're less careful about it. So I really recommend bubbles. All right. So then what you want to do is you want to place your template onto a page. I really recommend that you place it in the same spot all the time. And I also recommend that you use a consistent setting for scanning, so you always get the same resolution. Another thing I really recommend strongly against is any overlap of the content of your document with the OMR template you're looking for, okay? So make sure they don't overlap. Don't do the little overlapping lines I have there. That was a bad idea. It didn't work out well. Try to give it some white space margins such that you can crop it out, okay? Now, I'll answer questions in the YouTube chat anytime you want. But once we've got a scan of the document and we want to find the OMR thing, we have to find the template. But how do we find the template? Well, you can use object detectors like orb or sift or other things, or you can compare pixels using template matching. I really recommend starting with template matching because it's simple and powerful. Now, OpenCV has a bunch of tutorials on template matching, and the general gist of it is that you've got an image, you take a little thing in the image, and then you basically just search every single pixel in the image, and you look to see what the difference is. And what you're doing is you produce this image of the maximum difference. So you've got some kind of difference function between like two images, and you just plot the difference, and you find the point that's the maximal. And that's really what we're going to do with template match. So to review the algorithm, the input is a template image to find and another query image to find the template in it. So we're going to use this as the template, and this will be the query image. Okay. So if you have any questions, just type them into the text chat and I'll answer. The output of template match will be a similarity map per pixel. The max similarity is the likely location. And Alexander Wong asks, how robust is OpenCV's template matching to rotations? It can handle probably 3 to 4 degrees any direction pretty good. So you really do want to correct your images if you can ahead of time. So sometimes pre-processing is totally worthwhile and will do a lot better performance than, say, using a stronger classifier or something like that. Really consider cleaning the images before you use them. And when you find the image, consider correcting them to a common orientation. So the template match, it looks for the template image, it makes a new output image, and the output image has every single pixel be the distance of that subregion that matches your template. That distance will be that pixel value, okay? And then, so you'll basically get an image where it shows you the pixel distance, or it shows you the distance per pixel, and then you try to find the one that's maximal or minimal depending on what your similarity or distance measure was. And OpenCV has multiple that you can use. After that, you go through that image and you choose the best candidates to find the best locations of the templates. Its input is the template match output image that you just did, and its output will be the location, the most likely location of the template. So basically, you find the location that has the most similarity, and you return that location. It's basically argmax of all locations for distance. Now, the benefits of this is, given its assumptions, it's very robust and it's very strong and it's very fast. It is so fast that if you wanted to protect against rotation, you could rotate your query image a couple of times and do the template match on all those rotated versions, and then you could tell if it matched. So that's pretty important because that means you can ask this many, many, many times, which is quite helpful. Its weaknesses is it is basically not invariant to linear transformations. It can't handle rotation very well. It can't handle flips or mirrors, and it cannot deal with scaling very well. So you want to make sure that your input images are of the same scale. So how do we actually use OpenCV to find this stuff? Well, let's go look at this find template code. I hope you can read it. The find template code takes in an image as input. This is the query image, and it takes in the template image. We convert our input query image into grayscale just to make things easier. And then we run OpenCV match template, and we give it the grayscale image, we give it the template, and we give it a distance measure, right? So the distance measure I used is called, I think it's this one, CM TF coefficient normed, and it looks like this, but that's not super important. You can choose different ones. You can use just square distance if you want. I recommend testing them. And then what you can do is with this image, you can ask OpenCV to find the min and max locations. And it'll give you the min value, the max value, the location of the minimum value, and location of the maximum value. For this measure, we want to look for the maximum value. So I use that as the main point. And then we basically extract a sub image. So I'm just saying, given this NumPy array, grab this region and this region, this height region and this width from that, and make a sub image and then return it all. Okay. So how does it actually work? Well, let's take a look. So here I'm going to read in this one image. It's called safe blanks PG053. You can see it right here. So it's this exam. And then I read in the blank, and the blank looks something like this. And then I say find template, and I give that image, and it returns the sub image and the point and the result. So I print the point, which you can see right here. And then I plot the input query image. I plot, I wonder why this code works. Combo. I'm missing some code here. And what I did is I added the res image to the combo. And so what we're doing here is we're basically showing in this image, right? Yep. In this image, we can see that this pixel right here, this little yellow pixel, is the hottest pixel. And that means that that corner matches this corner, and all the pixels here are aligned pretty well. And so we'll assume that this is the best location. And then this is the sub, which is what it extracted, and we're able to pull that out. All right, I got a bug here. I got to fix that. Fix combo. All right, so how do we extract the template from the image? We basically call our find template, and we return the sub. We can extract it from a file name just by using OpenCV's reading function. Okay, so what we've really done is we can see from the pixels here that it's going over, and it's basically just telling you the distance between your input template and that pixel location. Okay, and this is very powerful. This means you can find the location on the picture, but it doesn't tell us what the things are. We have to figure out what the marks are. Unfortunately, I had a lot of really great examples, but I can't show them because they have student numbers in them, and that would be private information. So we've got to go on a bit of a side quest. We have to generate training data or test data just to use this thing. So we're going to generate synthetic data. Synthetic data generation is actually pretty useful in this case because it allows us to generate lots of examples and do very robust testing. So to do synthetic data generation, what we're going to do is we're going to load up one of those templates. We're going to choose a number, and then we're going to fill out the template, and we're going to save that as an example. So to do that, I set up a couple of things. I did n digits, how many digits we got. I went into the GIMP, and I looked at the pixel locations of each column and each row. So what was the average center pixel location? And I wrote down the column X coordinates and the digit Y coordinates. So using these, you can triangulate any kind of digit. Then I suggested how many pixels wide was the actual box we're looking for, and I said it was about 16 wide. Okay. Now I have to fill these in. So what I'm going to do is I'm going to fill them in with noise. This one's kind of complicated. Or I can fill them in with the color black. I do this by simply multiplying all the pixels by 0, black being a 0 value. So I can just take a region in NumPy arrays and I can make them black. So if you have any questions, just type them into the chat. I'll totally answer them. So now that I've got make noise, make light noise, and make black, noise just applies normal Gaussian noise. I give these options. I choose one of the options, and then I just apply it to my image. Then to label an image, what I do is I make a copy of your template, and then for all the digits that you gave me, I'm going to get the column location and the row location, and I'm going to fill in that box, okay? So here's an example of it running. So we go run, run, and we can see here that it loaded in my example blank, and then it labeled the image with all zeros. So here I've got 7 zeros, and we can see that it's got 7 zeros, and you can see there's noise in there. And then I did a 1, 2, 3, 4, 5, 6, 7, just a complicated way of saying it. And we can see we got 1, 2, 3, 4, 5, 6, 7. All right, cool. So now I can generate any data I want. I can make 999. I can do whatever I want. So if I wanted 999, I could just go do that and give myself like 7 nines. And then I can plot it for you just to show that it's a live demo. Boom. See, all 9s, right? Easy peasy. So any possibility. Okay. So now we've got a generator. We can make a training set and evaluation set. If you're using real machine learning, you should keep your training set and your evaluation set completely different. The training set is what we learn from, and the evaluation set is what we hold out and we evaluate our performance with. So I make a function here that chooses student numbers, basically just a random 7-digit code. And then here's one that generates, given the student number, it will make a labeled image with that number and return the label and the image itself. So here I can make a training set. So I ask for 100 of these, And here I can make an evaluation set, ask for 100 of those, and I'll just show you the first 5. So I will run this for you. So we go run, run. There you go, generated some random examples. Pretty cool. Now, what I want to do is I want to make a template. Again, I want to abuse the template match, and I want to make a template of a filled-in box. So I made a box. So I started with a bitmap of all ones, so high values, and then I made a black box using the make black box thing I had, and then I just plotted. So an exciting black box. I kind of like the color scheme. All right, so let's choose a random example and let's get to work on it. So I've chosen a random example. We chose it from the training set. I convert it into gray. I convert from grayscale to RGB just so I can draw on it. I get its width and height. And then I run CV match template on the gray image versus the box template. Now remember, the box template is this black box, okay? And what does it do? It returns basically this res value, and I basically unravel it, and I get a bunch of points. So I get 2 arrays, one of X values, one of Y values. I do some Python magic, and I zip it. And then what I do is I plot it, because this is meaningless. I want to see what it looks like. So we're going to draw rectangles, okay? We're going to draw big orange rectangles on every point. All right. So we run this, and we can see that there are 7 hot spots, so that's cool. And those hot spots are these spots here. And you can see that it did draw a lot of orange rectangles, although this is a lot of orange. So it's actually drawing many, many, many points. So now we have the problem that we have too many points. We really want to get individual points. Like these hot spots are cool enough. We probably could have just clustered on that. So what I do is I make a function that tells me if 2 points are similar. So given a threshold, are 2 points within the radius of this threshold? So this is just a Euclidean distance in comparison. And then I make a function that calculates the average of a collection of points. And then I make another function that goes through the points and takes a small collection of them, calculates the average, and makes sure that there's no similar points left in the list. So it basically reduces the list by removing duplicate points. So this just finds similar points and removes them, then returns the list. And I also made a function that detects to see if you got a white box. Okay, so if the average pixel color is too bright of that box, then it's a white box and we don't want that box. All right, so I take the points, I go and find the similar points, and then I remove white boxes from the points. And now let's go and look at what it actually found. So the orange was the original point locations, and now the blue is the current points. All right. All right, I'm not sure if anyone's still alive, so please slam F in chat if you're still watching and awake. Thank you. All right, once we've got these points, oh, excellent. It's nice to see people alive and well. Great. So once we got these points, we still might have too many of them. So I'm going to do something a little bit advanced. I'm going to use a clustering algorithm called k-means. What k-means does is you say, I give you 7 random points, and I want you to build clusters around these points, and you can move them. So k-means distributes points throughout the space, and then it tries to find locations that are central to groups of the points. All right, so I basically say k equals to the 7 digits, find me the 7 locations, like your Dragon Balls, I guess. And here it went out and it found clusters of points and it positioned them in the same spot. You don't always need k-means, but it does add a nice little thing to it where it does like a really good job. So I'll just run k-means on our example, and oh, it's horrendous. It just is totally wrong. That's not cool. Let me just make sure I've got this whole thing right. It can be wrong, but that happens. Yeah, the k-means is a little bit wild. All right, fine. Now, what we want to do is we want to convert those points into each digit. So we now have points. We now want to convert them into digits. So I've got a function called closest digit, which basically looks to see where you are and which probable digit pixel location do you match. So then we just map over all of our points to get our closest digit. And let's see if this thing's actually accurate. Oh, good. It's actually correct. That's really surprising because it didn't look like it was going to be right. So it basically finds the closest centers, and it goes and finds the closest digit, and then we just compare it, and we print out what it calculated. We printed out what we expected, and if it does equal what we expected. And we can see here that it worked out. And then to emphasize that we were right, I have it draw black bordered blue or cyan boxes. So it worked. Success, right? Awesome. We're done, right? No, we're not done. We still need to evaluate this. So to evaluate it, what we got to do is we got to make sure that when we label each one of those evaluation examples, that it has the same result. So here it's got to have the same output, okay, for every example or for most of them. So what I have to do is I have to take all this horrendous Python notebook, this Jupyter notebook, and turn it into actually useful functions such that I can call it again and again and again. Okay, so closest digit, points to digit, and finally a classify image function that matches the points, filters the points, converts the points to digits, and optionally plots them. Okay. Then I also have an accuracy function where it takes inputs and outputs, basically expected values and output values, and just compares them, the number of correct ones versus the number of ones given. So we're going to evaluate on the evaluation set. So first off, I'm going to run it 3 times, and I'm going to classify the first 3 evaluation set ones, and we'll see if we're right. Okay, so let me just run all this jazz, make sure that I didn't lose anything. So we'll go run. Okay, run. All right, so we can see the first one is correct. It got good. This one's correct too. This one's correct. Okay, so the first 3 are correct. And we can see, oh, well, that sucks. We got an accuracy of 1.0. If you get an accuracy of 100%, there's probably something wrong with your code. Just saying that. But maybe I got lucky. So this is artificial, and I don't trust it because I filled in all these blanks and I know it. What if it's leaking information somewhere? So let's make it a little harder. We're going to add rotation and noise to determine if we can really do, if it really does work. So we're going to abuse the images a little bit and see if it can still classify them. So first off, we're going to do rotate images. With OpenCV, they have a get 2D rotation matrix, and you suggest where the center is and the degrees, and then you have to warp it with an affine matrix. Basically copy this code, and you've rotated your image. Rotation still might not be enough. I want to add noise to them. So what I do is I get a list of inputs, my evaluation set. I'm going to shuffle them for good measure. I'm going to rotate them up to 5 degrees. I'm going to add almost 90 pixels worth or 90 values worth of noise to them. I'm going to rotate them. I'm going to add noise to them. See, I'm adding Gaussian noise right there, and I'm clipping it just for the heck of it. And then I'm going to go classify it. And then we're going to calculate accuracy. So I'll run this again. This better not get 100% accuracy. All right. So we can see here that it was actually pretty successful in labeling this one. This is what they look like. They're very noisy and kind of bumpy. And oh, good. We only have 93% accuracy. So I feel better now. We can see here that it had a lot of candidates. It even thought the N was a candidate, and it got confused right here, and it went right in between them. For this one, it totally missed out one right here. So, you know, that's kind of problematic. For this one, I don't know. It just missed this bottom one. And then this one, it thought this corner was a corner, and it thought there was there. So it was wrong. So at least now I have some confidence that it probably is working all right. And if it can handle rotation and rotation and noise, I'm probably pretty safe. So I feel a little bit better about it. When you see an accuracy of 1.0, you should go into skeptical mode and you should think that you have a bug, because you probably have a bug. Now, how can we improve this situation? What if this is actually what we have? Well, if there is rotation, we can probably try to correct for rotation. Also, if I know that there's only 200 students in my class, I know that if this thing produces an invalid student number that doesn't match those numbers, it's wrong. So without even doing supervised training, I already know the allowable values. So if you know the numbers ahead of time that it can be, then you can check against them and you know when you're really wrong. But with data augmentation, you could consider other transforms like scanner noise, coffee stains, creases, problems with contrast. And you can basically, one of the cool things is if you can generate these, it means that you can also just say, generate one, you can generate 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 in the first column, match against that, and then generate 1, 2, 3, 4, 5, 6, 7, 8, 9 in the second column with the first column matching and match against that. You can actually kind of dial down and do basically 10 times 7, 70 guesses and get a good result too. So you can use a different algorithm. All right, so this is pretty fast, pretty furious. But in conclusion, the bitmap-based template matching is very fast and repeatable and is usually one of the most common solutions for successful OMR. OpenCV provides you with good template match code, and you should really consider using it as a first step. And realize, while I have really great accuracy for some of this, if we actually placed it on a real sheet of paper, and if we place it on a real sheet of paper, we still have to find where on the paper it is. So if we're not super successful at finding it, then we're not going to be super successful at decoding it. The probability of our total success is actually the probability of finding it times the probability of reading it. So if we're 90% good at finding it and we're 100% good at reading it, we're only 90% good. If we're 90% good at finding and 90% good at reading, we're only 81% good at the whole shebang. Generally, cleaning your documents up with pre-processing will result in way better results than a lot of the later steps. And consider clustering techniques so you can deduplicate points. Now, you might have real hard questions like, what if I want them to use the cell phone to take a picture? Well, some of these little resources I give here can be quite helpful. Image alignment tutorial can show you how you take a cell phone photo and align it and transform it properly before you put it into the scanner. All right, I covered way too much stuff, but I hope you got something out of it. The talk is on GitHub, and I'm definitely willing to take questions right now. So please slam questions in the chat, and we'll do that for a bit. Thank you for your attendance.
All right. Sorry. I was going to say, I think Alex got a question there.
Students have to be able to type in their have to be able to scribble in their student number correctly. There were actually quite a few mistakes where people wrote in numbers that were legitimately not their student number.
And you were able to, figure that out because you already had the list of names and numbers, like you had said, that you could look at ahead of time?
Yeah, so if it output a number that's not in the class, either they dropped or that was a problem. And you could often correct for that.
Okay.
And, it was small enough. But I used this this thing dealt with thousands and thousands of student exercises. So it's okay.
Great. So then at the moment you said the solution right now with its assumptions to get it to the point where someone could say use their cell phone to take a picture, you're saying the first step would be to look at that image alignment algorithm and then apply that. But is there anything else that you might have to account for with like a cell phone image versus something that's coming off of a scanner that you orient things properly and have control over?
Well, you want to get the image sizes pretty consistent. That's a big thing.
Mm-hmm.
So you want to basically transform everything into something reliable, and that can be problematic. And also finding the image. In finding the template in the image can be quite problematic because you might have made a really messy document, or the user might have made a real mess of the document.
Right.
And so ALR asks, that's a lot of work. Can ML or AI libraries help with this problem? Yes, they totally can. And one of the big uses of them would be to initially find the location of your template. So a CNN would be really good at finding location of the template. And once you clean it up, you can probably train another CNN just to give you the digits. The issue is you really want it corrected for linear transformations ahead of time. Linear transformations are rotation, scaling, skew. CNNs are quite good at that, but the more you clean it up, the better you can get. Yeah, so like your TensorFlow and your Torch and you copying ImageNet or something like that can do a lot of good, but you can find that they get pretty, that you need a lot of data for that. So if you're going to go deep, you definitely need the generator such that you can generate tons and tons of these examples.
Right, I was actually going to ask about that because from your example in the talks, you don't have the same level of data that I've heard you would require to like train your CNNs and whatnot. And yet this result here is actually pretty good.
Well, okay, so this result is really excellent because we use the same scan template and we rotate the same scan template. So it doesn't suffer from the paper folding, it doesn't suffer from different printing, it doesn't suffer from different pixels being off.
Right.
So that's a benefit. Also, if you look on my screen right now, you can see these are all filled in real good, right?
Mm-hmm.
Sometimes people use colors like pink and stuff, and they don't come through on scanning. And that's where you see a lot of different errors. Also, people like X's. That's why I recommend against using boxes. They love putting X's in boxes. Those are harder to recognize than a filled in square. So there's a lot of real world issues that you run into, but data augmentation, such as adding noise like I've shown here and rotating, can mean that you can bootstrap off of maybe 100 labeled examples. So you could take 100 labeled examples that you did by hand that, say, students wrote in, and you could rotate them all sorts of places. You could add all sorts of noise. You could put virtual coffee stains on them and everything like that, and you'd get a nice kind of deep learnable data set.
I see.
But also realize that some of the deep learning is just going to learn exactly the transformations you applied. So it's relatively clever in that respect. All right, so do we got any other questions?
Nope, doesn't seem like it.
That's fine. Yeah, so check out the references, especially on template matching. I think they do a good job of that. And OpenCV has really great Python documentation.
Okay, and I did see there on the last link in the references section that this notebook itself is on GitHub?
Yeah.
Perfect.
Yeah, it's right on GitHub.
Okay, right on. So now people can take this and try it out on their own computers and give it a spin.
Mm-hmm.
Perfect. Okay. Well, thanks, Abram, for the talk. We got a question. Is the app interpreted or compiled well?
It uses NumPy, so the mathematics are mostly the mathematics are calling to usually Fortran code. So it's in many cases this is as fast as you're going to get. OpenCV is a C library with some Fortran in it too, so it's pretty fast. So as long as you keep using OpenCV, NumPy, and anything that's actually compiled and performs well, you're good. The way that you write really slow code in Python for this kind of thing is you use Python for loops.
Right.
If you can do it using linear algebra in NumPy, it'll go way faster. Yeah. All right. So I'll leave it to you to close out, Aaron.
Okay.
Thank you.
Thanks, Abram. Yeah, so just to close it out, let me just bring up the... let me just bring up... Oh, let's see. Well, since there is no next event, there really isn't anything for me to bring up. So I guess I'll just thank everyone for attending this month's meetup. And we're going to see if we can make it happen again in June. But like I had said earlier, we are looking for speakers. I can just find the slide here. We are looking for speakers. Talks can vary in topics. They just have to do with Python in some way. If you've tried out something or you've learned something or you've learned from your mistakes, odds are you're not the only one. And who knows, you might be able to help another beginner maybe avoid some of the mistakes that you had encountered. So again, please reach out to one of those 4 individuals on the Dev Edmonton Slack. We're all, including Abram, part of the EdmontonPy organizing team. So we look forward to hearing if you do have a talk, even if you just have an idea. We are interested in helping guide you to turn it into a presentation and to help you as much as we can. So again, we are encouraging people to create presentations, approach us, and we'll see if we can make June happen. Until then, I'd just like to say thanks to everyone who's been here, and hopefully we'll see you next month.
Thanks, everyone. Bye-bye.